And again, a little bit of review. I'm going to point out, mostly I want to concentrate on the areas of error and then the notation for your solutions on these inequalities. We want to move away from your solutions being x is greater than or less than, or an x is between, to the interval notation that the IB and the calculus classes are using. So we're trying to set you up for that. You know, you've done solving linear inequalities for a long time, all the way back to pre-algebra. You know that solving them is pretty much the same. Number one here, you can add and subtract both sides, nothing changes. You can multiply and divide both sides by the same positive number, nothing changes. The only exception is when you multiply both sides or divide both sides by negative, then you have to reverse the direction of your inequality. Greater than, make it a less than, and so forth. Okay, so nothing really out of the ordinary here. This is new. The interval notation that we're going to be using is an IB notation. The calculus class is now using it. I think that that's what they're using on the AP test. So we want to make sure that we're getting the idea of interval notation. And in the IB, we're going to be using brackets. So this is the way I want to go. You've done it with inequalities. When you say this or this, you may have learned how to do it with the parentheses in the brackets, but what we want to use is this either open bracket or closed brackets, or however you want to think about them. You come up with words that work for you. If it's a greater than or less than, you use the opposite facing bracket. Bless you. Bless you. Means you're not going to include the boundary. And I'll explain that a little bit more. But if it's greater than or less than, whatever your limit is would be an open circle on a graph and it's not included. Whereas if it's greater than or equal to or less than or equal to, we use the closed brackets, and means we're including those ends, those boundaries. Somebody a couple of years ago, a year ago, said this is hugging the value, so we're hugging -2, which means we're including the -2. And then we are shunning, when we do this, you're not including that one, you're shunning them from the group. So it looks like this. So we're shunning the 7 and shunning the 28. So your region is going from 7 to 28, but it's not including the 7, and it's not including the 28. This is the old interval notation, which we're not going to be using. And this is what you learned back in your algebra classes, pre-algebra and algebra classes. This is the notation that we're going to be adopting here. So everyone is going to use that notation. Know that you have all these other alternatives as well. Okay? So you have a situation here with 4 examples. I'm going to do the first one. And they're very easy. It's going to take you about 20 seconds before I finish. Some of you will be done with all of these. The key, though, is being able to identify what the answer looks like with this new notation. We're going to add 8 here, and we're going to get x is less than -4. In order to show that x is less than -4, you're going to go to -infinity, comma, to -4. We're going to shun the -4, and you can never get to -infinity. So you will never have a bracket closing or hugging the infinity. It'll always shun the infinities. Okay, so you can never have an infinity on either side, positive or negative infinity, and have the bracket hug that infinity sign. Your numbers in here are your limits from least to greatest. So the greatest value x could be would be just under -4. It's all the way up to, but not including -4. That's the shun. Then goes to a negative infinity, and we always shun the negative infinity. Okay? See if you can notate the other three of these four. Have your paper. Take a second. Go ahead. All right, let's do number 2 down here first. What does that solution end up looking? What do we end up with here? Did anyone get this? Honey?
So you have the bracket.
No, tell me the solution first.
So y would be less than.
Greater than?
No, so if you're multiplying these two.
What are you multiplying by?
2.
Positive or negative?
Oh, so only if it's a negative.
Only if you multiply or divide by a negative.
So then it'd be y is greater than negative.
Y is greater than -4. So then we're going to go shun -4, comma. Infinity. And then you shun that. Everybody follow that? Simple, theoretically. When we solve this, Taylor, what did you get here? -30. So what's your notation going to look like? Okay. Correct. Close the bracket. Hug it. Okay. So if you're looking at this from left to right, the boundary is on the right. The boundary is at -30. So we are including the -30. Going left, and it goes to infinity, negative infinity. If you were to graph it on a number line, you would start, here's -30. You would have a closed circle. It would go to the left, here's 0. Okay. Be careful on this last one. It's easy. You just have to make sure you're doing order of operations correctly. Max, what do we do first? I know you haven't done it yet, but
yeah, you minus the 1 from both sides.
So what do you get?
-2d is less than or equal to 6.
And then what?
You divide -2 out both sides. D is greater than or equal to -3.
3. So what's your notation going to look like?
Shun 1.
We're not going to shun it. It's greater than or equal to.
Oh, greater than or equal to -3.
So we start at -3 and include it. Hug it.
And then infinity.
Yeah. Go to infinity.
And then other shun.
Anyone see any issues with these 4?
How do you know if negative is not wrong?
Least to greatest. So y is greater than -4. The smallest thing you're going to have is -4. And you're going bigger. Does that make sense?
Yeah.
The smallest thing we have here is -3. We're going bigger. On this one, the biggest thing you can get is -30. And we're going to the left. We're going smaller. So negative infinity all the way up to, and then you stop and you get to -30. So from left to right, we're at infinity and we go to -30. Whereas here, we're going from all the way up to negative infinity, go, and then when you get to -4, you stop, but don't include the -4. So it's from least to greatest, left to right. Okay. Anybody else on the notation or how to solve? Okay, try these 2. A little more complicated. All right, Frankie, what are we doing the first one?
Well, I started out by adding 4 to both sides and subtracting 6.
Okay, I chunk, it's earning one shot. 2x less than or equal to 14. So x is less than or equal to 14. So your notation?
7.
Yes. See if you're paying attention.
You shun negative infinity on a 7.
Okay? That's all you need. That's your answer. So right here is what you're going to be giving me as your final answer. Okay? Luke, how about the next one?
Multiply by 5.
Okay? Hey. Yeah, give me a second here. Jeez, the patience thing. And then what? So what's your answer look like? That's pretty simple stuff. Nothing really new other than the notation on how to answer. It doesn't matter whether I teach this in Algebra 1 or Honors Pre-Calculus. I have a group of students who say, oh yeah, I get it. And this is how you do it. And I have students who say, oh no, I don't need to do all that work, I can just do this. Those people make mistakes at a high rate, a very high rate. Absolute value. If it's an absolute equals, you're going to get answers that are just single integral answers or numeric answers. So if it's absolute equals. If it's absolute is less than some constant, then you're going to get an and situation, which means you have an overlap. If it's less than or equal to, you're going to get an overlap or an intersection, which is an and situation. And if you have absolute is greater than a constant, you get an or situation where you get two things and you have a union, and you have to use the union to demonstrate what your solution is. Knowing this can help you identify whether or not your answer is a legitimate answer. It's not important, it's not critical to know it, it's just a good piece of information to have so that you're on track to get the correct answer. So greater than, absolute greater than a constant is an or, absolute less than a constant is an and. Ands are overlaps, ors go away from each other. Especially in Algebra 1, I make a big deal of this. And some of you have had me for Algebra 1, maybe, definitely, and some have been in Algebra 2. Here's the thing. If you're doing absolute values, and I've been teaching these and been a student for a long time, so I'm really good at this. If you can do this, let me go slower. That's probably too fast. You can do that. You can solve absolute value inequalities and equations. Backwards. My eyes closed. See? If I had to, I can even do it left-handed.
Oh,
Very well. I can do it. Look, this is all there is to it. And here's the drill. Get the absolute value by itself on one side. So if there's other things with it, get the absolute value by itself. This one, the absolute values are already by themselves, so it's not a big deal. Write the problem down twice with no absolute values. The second time that you wrote it down, put parentheses and a minus, and then just solve the two situations separately. If you're looking for a better way to do it, a faster way to do it, There are faster ways, and they almost always lead to a high rate of not success, failure. This is the way to do these problems. So if you're looking for a shortcut, I would recommend against it. So when we solve this, we get x equals 8. When you solve this, and then the best thing about them, when it's an equation, just plug it back in and you can check it. So your solution here is x equals 2 comma 8. It's not an inequality, so we don't use interval notation. With the inequalities, again, x minus 1 is less than 2, x minus 1 is less than 2, and in the second one, where the absolutes were, we put parentheses with a minus in front. When we solve, we're going to get x is less than 3. When we solve over here, you have negative x plus 1 is less than 2. Negative x is less than 1. And x is greater than negative 1. If you look at that graphically, here's negative 1, here's 3. If you look at it graphically, you're going to be open circle on the negative 1 to the right, and open circle on the 3 to the left. There's your overlap. This was absolute value is less than. Absolute less thans are overlaps. So what will your notation be to show the solution? What's the IB interval notation going to look like? Shun negative 1, and then shun the 3 also. That's your solution. Absolute less thans have to be in overlap, so you're going to be between these two values. So if we write it down twice, x plus 3 is greater than 2, x plus 3 is greater than 2, parentheses and a negative on the second one. How you doing? X is greater than negative 1. Negative x minus 3 is greater than 2. Negative x is greater than 5. X is less than negative 5. These, if you look at them graphically, here's negative 5, here's negative 1, here's 0, would go away from each other. When they go away from each other, that's an OR situation. Either one would be an acceptable answer. So you have to look at those as separate intervals. The one on the left is going to be shun negative infinity all the way up to negative 5, and we shun the 5. The one on the right is going to be shun the negative 1 all the way up to positive infinity, which we shun. And both of those are acceptable answers, so the symbol that goes between them is a union. So we have the first interval on the left, union the second interval on the right. For an OR situation, that's the only way you can do that, unless you use one of the other notations. Is everybody okay with that? Any questions? Okay, try these two. Alright, so the first one, 3x minus 9 is greater than 4. 3x minus 9 is greater than 4. And then we take the opposite of that. And again, there are other ways to do this. And there, you can walk down the hall and you can go next door and Stedman does it different. The kids who don't do it this way, the kids who do one of the other ways, they switch the sign and change the right, they make mistakes at a much higher rate. This way, you take care of the change as a result of something that you're doing. So here we solve, we get 3x is greater than 13, and x is greater than 13. Here, negative 3x plus 9 is greater than 4, negative 3x is greater than negative 5, and x will be less than 5 over 3. Is this an and or an or situation? Is it an overlap or going away from each other? It's an overlap? No, it's an or. They're going away from each other. So that means we have to have a union. So we need to have a union here. So we're going to go interval on the small side, negative infinity, all the way up to 5 over 3. Union, 13 over 3, positive. Yep.
And you're not allowed to write that second one first.
Least to greatest, from left to right. So the left interval, the leftmost values, is the smallest. So negative infinity to 5/3, union 13/3, positive infinity. Always want to go from least to greatest. Okay, on the bottom one, 2x plus 5 is less than or equal to 7. 2x plus 5 less than or equal to 7 with parentheses in the negative. Now, what's this solution going to look like? This should be an overlap, and it should have brackets that are hugging. We know it's an overlap because its absolute is less than a constant. So we're going to go with 2x is less than or equal to 2, and x is less than or equal to 1. Negative 2x minus 5 is less than or equal to 7. And x is greater than or equal to negative 6. So we're going to be from negative 6 to 1 is our interval. Good? You'll take a little bit of time to get used to this notation, but once you get it, it's pretty easy. When you have absolute is greater than, either greater than or equal to, you have an or situation. That means you have to do a union. If you have absolute is less than or equal to, you have an and situation. That means you're going to have one interval as your solution, an overlap. This is how we used to write the ands. We used to solve for x and then put x in the middle, least to greatest. That was algebra 2. Some people say, well, we could do it this way and write two intervals and just put and in between them. That just seems like extra work. This is algebra 2, algebra 1. We're using the interval stuff. Excuse me. When you have an absolute value in between two constants, you have to separate and solve separately. So you're going to get this situation. Cover up the inequality on the right, so you get x plus 3 is greater than 0, or 0 is less than x plus 3. If you want to write it like this, that's fine. If you would rather write it like this in red, which is just covering this up, that's fine too. And then cover up the other side where x plus 3 is less than 1. Which one of these right here on the left, they're the same thing. They're pointing at the 0. Pointing at the 0. It doesn't matter which way you write it. If one makes more sense to you than the other, then do that. And then solve them simultaneously. So when you solve this, you're going to say 0 is less than x plus 3. 0 is less than x plus 3, parentheses with a negative. 0 is less than x plus 3 is going to give you this. So you have x is greater than negative 3, and x is less than negative 3. Okay? So it's everything except the negative 3. So it doesn't, if the only thing that's going to screw this up for you is the negative 3. And then over here, when we solve the second one, you have x plus 3 is less than 1, and the opposite of x plus 3 is less than 1. When you solve this, you get x is less than negative 2. And x is greater than, bless you, negative 4. So in this situation, if you're looking at it graphically, here's negative 4, here's negative 2, you would be looking at this situation. On this one, we would be looking at negative 3 going in both directions. It's everything but negative 3. What do we need to have in order to be the solution? In order to be, again, the original problem is up here.
Shun negative 4 and then negative 3. And then shun that and then negative 8 and then shun negative 3.
So you want to go from
I don't know.
negative 4 to negative 3, union
Negative 3 to negative 2.
to negative 2. What did you really find? How do you describe what we just wrote down? Well, this is an and, actually, because it's absolute value between these two. It's this greater than this and greater less than that. But what did we describe here? Yeah, you described an or. So this interval or this interval. Where did these intervals come from, I guess is what I'm saying. What about it? And so what do we call that? Begins with O, ends in verlap. Overlap, very good. Okay, it's the overlap of these two. Do I need to go slower on that? Okay. So you're looking at the overlap of those two to get your solutions. The negative 3, everything but negative 3 works great, but it only works great on this side. It doesn't work great on this side, and vice versa. So you have to come up with a way to handle this that's going to work for you consistently. You're looking for an overlap on that. This is a, okay, yeah, I get it, I hope, no work problem. As soon as you have an absolute value isolated, it doesn't matter what's in the absolute values. Absolute value of anything is less than a negative number, not a chance. Absolute value is undirected distance, distance from the origin, and distance is always positive. There's no way you can have absolute value be less than 0, and certainly not less than a negative. That's always going to yield a no solution. You do not have to do any work for that. Okay. I'm not sure if this number is correct. It is correct?